This is a discussion about combustion. Remember that liquids and solids do not burn. It is the gas produced when a liquid or solid is heated that actually burns. If you look closely, you will see that the flame is slightly removed from the surface of either one. My first example is a kitchen match burning in air. As I first strike the match, the sulfur compounds on the head of the match produce a combustible gas, and the heat of that flame causes the cellulose in the wood of the matchstick to give off a gas that burns. This is an incomplete combustion, indicated by the yellow flame. I can improve this combustion by burning the match in pure oxygen, rather than air, which is only 20% oxygen. See how the additional oxygen supports the combustion when I plunge the match into a beaker of pure oxygen. The next example is a simple candle. As I light the wick, the heat changes the solid wax to a liquid, which is sucked up the wick and heated to produce a gas that burns. The yellow flame indicates an incomplete combustion. I can collect unburned carbon and soot on a beaker placed above the flame. Again, if I surround the flame by pure oxygen, the combustion is much more vigorous and complete, as you can see. Note that the combustion is still not truly complete, as indicated by the yellow color of the flame. But the paraffin gas does burn much better when there is plenty of oxygen available. Now here's 3 drops of gasoline. I'm going to light it up in the open air. And you can see it's a yellow flame. It's not real energetic, and there's a lot of carbon coming off the flame. So I'm getting a poor combustion, far from complete. That's the same amount of gasoline that I'm going to use in the can. I'm going to light this meeker burner. Now you can see there's a nice blue flame and some orange and yellow coming off of there from incomplete combustion. But watch what happens if I close off the air. See how the flame goes all yellow and orange? And I'm getting very incomplete combustion. And there's a lot of carbon coming off of there too. Now, and then as soon as I let the air back to it, I get that nice blue flame that indicates complete combustion. I didn't adjust the gas in there. All I was doing was closing off the airflow. Here's another example of incomplete combustion. This is an acetylene flame. Notice all the carbon, unburnt carbon coming off of the flame because the combustion's incomplete. Now luckily this is convenient because I can add oxygen to the flame. And once I get a complete combustion, I end up with a very blue flame. And all that unburnt carbon is gone away. Okay, here's my gasoline going into the can. And I'll put the top on. Make sure that I've got plenty of air on the gasoline. And here we go. Okay, that was actually perfect. As you can see, it blew the lid open, but only a little bit. It didn't actually raise the lid off of the can. So that was a good, I'll double that amount of gasoline on the next try. Okay, this is double the amount, roughly, of the gasoline. Spread it all around. Get my lid on. Make sure that we get the gasoline properly atomized. And now, let's see what happens. I'd say that was the perfect amount. This is alcohol burning in open air. Notice the blue, almost invisible flame indicating complete combustion. Alcohol molecules carry their own oxygen, which helps to completely burn off the hydrocarbons while the alcohol is transformed into carbon dioxide and water.